Welcome to another yet very important lesson. Today, I know we have been learning of physics concepts several times, and we have had the interactions of difficulties as well as the easiness of how to learn concepts. I know those who are studying physics and those who intend to study physics, at one time or the other, you will definitely encounter some shock, meaning that you might encounter a period where something happens which you are not expecting. And so this one, I've called it a shock. And therefore, even as we are learning physics, it's important that we prepare for these shocks before they happen to us. And we look at as well the causes of these shocks, as well as how we can mitigate these shocks. In other words, we need to know the methodologies of adapting to shocks in the learning process of physics. Because physics, at one time or the other, you might not be getting 100%, which can give you a shock of the day. And so today, that's what we're going to discuss. We will not look at figures, but we'll just look at how we can actually mitigate vulnerability to these shocks. And here we go. And as I stated earlier, that today we're going to look at adaptation to shocks in physics performance. What I mean is that there will be at least a time when you would perform not the way you expected while in the learning process of physics concepts. And so, first of all, I'll shortly define these terms that I'm going to be using here. One of them is a shock. What is a shock? Really, a shock is a sudden upsetting event. Maybe you expected to get 100% in a physics test, and yet you get even something lower than that. And also, it's a surprising event or experience. At times, what you expected does not really happen. So at least as you are learning physics, these events will definitely happen. And the other term we encounter as we are discussing adaptation to shocks in physics is actually vulnerability. Vulnerability here will mean actually the quality of being exposed easily to physics shocks. How is it that you can easily encounter this upsetting event? So that's what vulnerability will mean here. And then resilience. Resilience here, we will use it to mean the capacity to recover quickly from the physics shock. When you have a shock, you wanted to get 100% in physics, and suddenly you get 30%. How do you recover? Or spring back into shape after you have had an encounter of a shock in physics. And so these are the three terms that I feel we needed to learn them before actually we go into the issues of how we can adapt to these shocks. The shock vulnerability in physics would mean that at times these shocks can come if we have a poor background in concept development. So at times we are not exposed to the ideal learning process, and therefore we become vulnerable. Such that at any time we can easily encounter a shock because we miss certain concepts. And secondly, we can also be exposed to poor delivery of what we are learning. At times, probably is it the teachers or the lecturers, they might not deliver the concepts appropriately, and therefore we can encounter these shocks. Also, even as a learner, if you are fond of missing lessons, certain lessons you don't actually attend to them, you are likely to encounter a shock because as you may be aware, the learning process is incremental in nature. It means that when you learn a concept, again, you have to add on the same concept in the lessons to come. Also, learners who are not serious at all, at times they take things for granted. During the learning process, they don't take much attention, meaning that they don't grasp the concepts which are required at the appropriate time when in the learning process. Also, will easily expose themselves to vulnerability shocks in physics. Also, there are also support functions. At times, maybe this learner loses the beloved ones, and therefore also they lose the support function in terms of probably having extra lessons. Also, probably do not have the machines to use this process online functions or opportunities. And so these loss of support functions can have a devastating effect on the learning process of physics, and therefore you can easily be actually exposed to shocks. Also, the poor learning environment, at times there are no learning aids or even equipment to use to help us to easily understand the concepts we're learning. So these can also expose us to vulnerability in the learning process of physics concepts. And so there is a diagram here that I've drawn. In the y-axis, we have the development of concepts, and in the x-axis, we have time. And so I know this diagram has been used several times when we look at vulnerability or recovery of people when they are exposed to climate change. But today, we are using this concept in physics. So in other words, what we are saying is that when there is a shock, something happening that you never expected to happen in the learning process of physics, this is the shock. The learning process for everyone here is smooth, and suddenly there is a shock here. Definitely everyone will be affected. Instead of following that pattern, smoothly going up there, everyone will be. Now the point we are interested in is this point here, the recovery period. When there is a shock, in essence, we expect that everyone should quickly recover, but that's not actually what happens. We find that others, they recover early. So ER here means when there is a shock, you easily recover early and come back to track. And the others, they recover rate. You can see this diagram here, mean that it takes long for you to recover. And the others do not recover at all, not recover. So the ideal one is that everyone who experiences shocks in physics should easily recover. But we have seen that many times the learners, some of them, they recover very late, and also others do not even recover at all when there is a shock. And this exposes them to actually not performing very well. So it's important that we understand this diagram so that we can easily continue developing the concepts in an appropriate way when there is actually a shock. And so that's what I meant when I said ER stands for early recovery from the physics shock, and the LR, it means late recovery from physics shock, and the NR, no recovery from physics shock at all. So this is very important to learners because even in the learning process of physics, we need to know that when there is a shock, we easily recover. And so there are risks involved, and therefore we need to find the ways of reducing these risks to these physics shocks. And so this is called the risk mitigation. And so how do we mitigate against the risks in physics? The risks of these shocks in physics. One of them is the consistency in studies. You should ensure that you do not have lapses in your studies, meaning that you should follow a certain pattern, meaning that the development of concepts should be consistent, meaning that you build on concepts one after another. Also, you have to be prepared. To avoid risks, you need to prepare at all times. Make sure that you start such that at times, as you are learning you might find that the time when you want to actually maybe write examinations, you experience something bad, okay? Or probably you miss a certain step, and therefore, but if you prepared early, it means that you can easily recover, or you can easily mitigate the shock. So there is also the aspect of quick response to correct the situation early. At times, certain learners, when they have a shock in physics, they do not perform according to the way they should have performed. They take time to correct the situations. So we need to have a skill of identifying the problem early, and then we make a quick response. And then the ability to recover early to the shock is a very important aspect, because it actually exposes us to know on our own without others telling us that things are not going well. Also, the prevention measures, we need to prevent against these shocks. And the many prevention measure is that we need to identify early the vulnerability causes of these shocks. And so resilience, as we indicated, is we said that actually resilience means that we need to have the capacity to recover quickly from an event or a shock. And therefore, we need to know the recovery time. We need to know how to measure recovery time when we have a shock. Also, we need to create opportunities to change the situation early. When we have a shock in physics, we need to know how to find opportunities to change the situation early. Also, what's important here is managing change. Managing change is a very big concept, because it requires that when there is something, do you feel just sit back and complain? No, there is the positivity that you need to actually have. And so this lesson today has exposed us to concepts we need to learn in order to avoid shocks in physics. And so next time we'll continue with the learning process. I hope this will be very important, because physics is integrated in many concepts that we learn, as well as the other courses and the subjects that we learn. And we need, therefore, and there is a tendency for many learners not to love physics, because it's more of actually mathematical. And therefore, I thought this lesson will help us to know how to mitigate against these shocks that we might experience in physics. I thank you.